Hey guys, welcome back to the channel. So in our previous video, we learned about user-defined functions. That is, how can you write your function yourself? What are parameters? What are arguments? What is the difference between parameters and arguments? How we can return values? How can we write functions with multiple parameters that returns a single value? How can we write functions that have multiple parameters and can return multiple values? Then we also learned about the tuples data type. In this video, we are going to build upon that knowledge and even go more advanced into user-defined functions. In this video, we are going to learn about scope in user-defined functions, what does it mean, what are the different types of scope. Then we will be going through a ton of examples to understand what is the difference between these types of scopes. Then we will be trying to see how we can access built-in scopes. Then what are nested functions, that is how can you write a function within a function, how you can call a function within the return of another function, right? Then we will be learning about the closure property, then how we can change values, right, from the global scope, from the enclosing scope, etc. Then we will be looking at some examples. What is LEGB rule? Then how to write default arguments in user-defined functions. What is the use of that? Then also we will be learning about flexible arguments, how to write variable number of arguments, both positional as well as keyword arguments, right? And then at the end we will be combining these knowledge. Okay, so let's jump right in. So scope is defined as the part of program where an object or the variable is accessible, right? So there are mainly three types. So for example, global scope, local scope, and built-in scope. Global scope is basically objects or variables that are defined in the main body of the program. So if you look at this, right, if you look at this, so this is the main body, right? And this is a variable x which has a global scope, which is accessible everywhere, right? So if a variable or a function has a global scope, then it can be accessed anywhere. Then there are some objects or variables that are of local scope, that is maybe defined inside a function. So once a function is executed, the object or variable ceases to exist, right? So for example, in this case, cube value is a variable which has local scope. So once we are done with this cube function, right, so there is no existence of a variable named cube value. And then there are some objects or variables that are built in, basically defined inside built-in modules, right? So for example, let's run this, right? So when I run this, right, so I have defined a function called cube which basically calculates the cube of any number you give it, right, and then stores it in a variable called cube value and then returns that value, right? Now after running this, right, so let me see what is the value of x, right? So x is 5, right? Makes sense. Here I have only defined it. We learned in the previous video that even though you write this, it does not matter, like until and unless you call the function, this def or whatever you write in this def thing does not execute, right? So let's call this function and try to find out the cube of a number called 10, right? So when I write this, obviously cube of 10 is 1000. And let's say after doing this, again I want to see like what is the value of x. Has the value changed, or like what has happened to x? So x remains the same because x has a global scope. So I can access, like even after running the function, before running the function, does not matter, right? But let me go ahead and access this, right? So since we called the function, these three lines were executed. Let me see like what is cube value, right? So let me run this and it says name error. Cube value is not defined. Why? Because cube value has local scope, and we have learned that once the function is executed, the object or the variable ceases to exist. So there is nothing called cube value, right? Okay, now let me what is the value of x? 5, right? So if I call the function with that value of x, what is it is going to return? It is basically same like just same as calling a function cube with the argument value 5, right? So if I do this, the cube of 5 is 125. Now let's go ahead and try to confuse ourselves. Here we have a variable called x is equal to 5. Now here x has global scope. Now again, same function, instead of cube value, I have replaced it with the same variable x. Now here also we have x, here also we have x. This x variable has a global scope. This x variable has a local scope, right? So if I run this and then I do call the function cube 10, again cube of 1000, right? So basically what is happening, cube 10 means, so when I'm calling the function cube and the argument is 10, so this argument is assigned to the parameter number you want to cube, then that goes to number you want to cube is raised to the power of 3, so that comes 1000, and then that value is assigned to x and then it is returned, right? So that is why we are getting 1000. But what do you think when I try to access x, what it is going to return, 5 or 1000? Because here if we return x, so it is giving you 1000, right? So let me run this. So it is 5. Why 5? Why this and not this 1000? Because this is local scope, right? And we just learned that once the function executes, the existence of this variable x, which has local scope, ceases to exist. Now this is very important. When I write x, so is it directly going to x is equal to 5 and trying to return that? No, actually the order is like, we will be learning LEGB rule, what it says. So basically when we try to find out a variable, so it first accesses the local scope, then it goes to the enclosed scope, which we'll be learning right after this, then it goes to global scope. But since, again same statement, since once this executes, there is no x, or x ceases to exist which has local scope. So it goes and tries to find out a x which has local scope, but it has ceased to exist. So since there is no nested function here, so there is no enclosed scope here, so it goes to the third in the line, that is the global scope, and that is how it is being returned. So when I say x, like return me the value of x, it is first looking in local scope, then enclosed scope, then it is going to global scope, right? So these three lines are being executed behind the scenes. Okay, so I just said that x has a global scope, right? So I have defined x as a value y, then I have function cube with one parameter, number you want to cube, then x is raised to the power of 3 as value is assigned to y, and then that value is returned, right? So let me run this, and let's say I want to calculate cube of 10, right? So I run this, it is returning me 125. Why it is returning me 125 and not 1000? Because I want to do cube of 10, right? So cube of 10 is 1000, but it is returning me cube of 5. Why? Because if you see cube of 10, I call this function cube and pass an argument 10. This argument is assigned to number you want to cube parameter, right? So number you want to cube becomes 10. Now the cursor goes to this one, right? So it says x is raised to the power of 3. So x is first searched locally, there is no x. Then it goes to the global scope. So x is equal to 5. So 5 is raised to the power of 3, that is 125. 125 is assigned to y, and then it is returned. So you see, even if you are passing it any argument, it does not matter because it is accessing the global scope, right? Okay. Now, if I change the value of x, right? So x is equal to 20. Now, if I do cube of 10, what it is going to do, right? It is going to access the new value. Cube of 10, 10 is being assigned to number you want to cube. Then x is raised to the power of 3. Now the value of x is 20. So 20 is raised to the power of 3. Value is stored in y, and then that is returned. So if I run this, it is 20 to the power of 3 is 8000. If I see x, the value of x is 20, right? So since we reassigned it, so the value of x has changed from 5 to 20, right? Now, let's say we want to change the value of the global variable in the local scope, right? So for example, x is equal to 5, right? So x here has global scope, that is accessible anywhere, right? Now I have defined a function called cube, again one parameter. Then I write global x. So this keyword global basically tells me that, okay, you can change the value of this global variable x now, right? So when I do x is equal to x raised to the power of 3 and then return x, right? So let me run this, right? And then I want to do cube of 10. So again, 10 is assigned to number you want to cube. Then I say, okay, now you have the permission to change the value of x. Then x is raised to the power of 3. Now this x is where? This x is being accessed here. So from 5. So 5 is raised to the power of 3. Then that value, so 5 is raised to the power of 3 is 125. Then 125 is being assigned to x. And since the above line says that yes, it is okay to change the value of this global variable x, so the assignment goes as it is, and then that value is returned. So when I do cube 10, it is returning me 125, right? And now when I access this x, right? So I want to access this value of global scope variable x. So what it is going to return me? 125. So it has changed, right? Okay, now let's get this concept clear, right? So it's kind of tricky, but that's the beauty of this, right? So again, x is defined as 5. So x has global scope, right? And I have defined same function. The only thing that I have not done is, write global x, right? So that is, I'm not giving permission to change the value of x that has global scope, right? Now, x is equal to 5. I have done this, and let's say I run this, and then I want to, calculate the cube of 10, right? So again, normal thing, no, not a big issue. I'm calling the function cube with the argument 10. 10 is being assigned to number you want to cube. Then it says print the value of x, right? So when I run this, the first thing that it should output is 5, because like this x is accessible here, right? And then it should be x is raised to the power of 3, right? So 5 is raised to the power of 3, that is 125. Then 125 is being assigned to this x, right? But since we don't have permission to change it, so basically that is going to give you an error, right? But what is happening, right? Let me run this. Okay, so cube, it is giving me a problem, unbound local error. So if you see here, right, if you see, it should, like, even though this line is, should give error because we don't have permission to change this x's global scope, because since it is a global scope and you have not written global x, so you don't have permission to change that. But why is this not returning something? And here, if you see, it is saying in this particular line only, local variable x referenced before assignment. But x has assignment, right? So this x should be this one. So it is not. So you see, remember this, it is very important. Exact same thing, right? The only thing that changed in this function, in this one and in this one, right? Exactly same thing is, instead of x being assigned that, that cube, a local variable y is being assigned that. So here, if I write, print x, right? Let me run this. So exactly same thing, right? And let me call the function and try to find out the cube of 10. So here it returns two things, 5 and 125. So 10 is being assigned to this. Then it says print x. So print x is being referenced, and 5 is, coming from it. Then 5 is raised to the power of 3. That is 125. 125 is being stored in y, and then that is being returned. And here the 125 is coming. But when I'm trying to do almost same stuff here, it is not even able to access this. So you see, that is the beauty of thing, and that you should keep in mind. Since we are not giving this Python code to change the value of the global scope, it is not even able to access this, right? So remember that, right? So it's very important to keep this in mind. Okay, so let me again, just for the sake of continuity, run this again, error. Let me see what the value of x is. X is still 5, but this is not able to access that. Very important, right? Now, what will this give, right? X is equal to 5. Define the function, one parameter. I have global x, so that means I can change x, right? Then I am raising x to the power of 3, and then the value is assigned to y. Then I am changing the value of x, so x is equal to 8, and then I am returning y, right? Awesome. Let me call the function cube of 10, then 125, because 10 is being assigned to this and I have the permission to change x. Then x is being accessed, 5 is raised to the power of 3, 125, y, x is being changed to 8, and we are returning y, so 125 is returned. Now if I look at x, what is the value that is going to be outputted? 5 or 8? 8. Why? Because we changed it. And why was this allowed and not this? The reason is this keyword, global, right? Because we have given the permission that, hey, it is okay to change the value of x, which has global scope, even in the local scope, right? So that is very important. Okay. So I hope this, you understood what is the difference between local scope and global scope and various scenarios involved in this. Okay. The third scope is built-in scope. You can, you write these codes, import built-ins and directory of built-ins, to find out all the built-in scopes. So there are a ton of it. You can go through it, like zip, type, tuple, sum, string, etc. They are built-in scopes. Then let's go to nested functions. So what is nesting, right? So basically one thing inside the another thing, right? So again, if you look at nested functions, so this is how the scopes look like. So outside of the outer function, so function 1 is the outer function and function 2 is the inner function, is the global scope. Then, between outer function and inner function is the enclosing scope. And then inside the inner function is local scope, right? Now, why are nested functions important, or why do we even need nested functions? Like, why to make things complicated? Okay, so let's suppose we want to do, one thing a number of times. Let's say we want to calculate like what is the remainder of various numbers when they are divided by 2. Let's say we have 5 different numbers, right? So if we don't need to, write nested functions, we will have to do the same thing a number of times. There were 5 numbers, so it's okay. But what if there are 500? Can you write this up till number 500? No, that is an issue, right? Okay, so this function has been defined, and let me call this remainder by 2 with the 5 different numbers and see what their remainders are after division by 2. Obviously this is an even number and rest all are odd numbers, so the even number remainder is 0 and rest everything is odd, and this is a tuple, right, with 5 different elements. Now instead of writing this big code, we can do the same thing by a nested function. So what we are doing is, again, the outer function is remainder divided by 2, like name of the function, 5 different parameters. Then inside this we are also writing define another function called rem, which is taking one parameter and then returning the number divided by 2. So basically the remainder, right? And in the return function of the outer function, right, or in the return of the outer function, we are returning a tuple and calling this inner function, right, rem, 5 times. So basically what is this going to do? So once I run this, right, so I have defined 2 functions and I say remainder by 2, right? So remember, remainder by 2, 5 arguments are passed, so 2, 3, 5, 77, 43. So it says, okay, goes to this and assigns 2 to num1, 3 to num2, and so on. Num5 is assigned 43, right? Then it says, okay, it goes, there is another function remnum, which is just dividing the number by 2 and returning the remainder, and then it is returning. So rem num1 was 2, so rem num1, so it goes inside rem num is 2, so 2 mod 2 0, 3 is num2, so 3 mod 2 1. So this is how this is working, right? Now if I see, okay, so what is rem5? I have written this function. Let me calculate what is the remainder when 5 is divided by 2. It says rem not defined. What is happening here? I just defined the function, right? This function rem has local scope, right? Again, once the function stops executing, there is no existence of local scope variables or objects, and here rem is a function object, right? So that is why, and since it has local scope, it is not able to be defined, right? Okay, now let's write a function to calculate the value of a number raised to another number, right? So define a function called power with one argument exp or exponent. Then inside there is another function, nested function assign base, and which takes another argument. You return base raised to the power of exponent, and then you return the function assign base, right? So here we are returning a function, right? So once I do this and I do a is equal to power of 2. So basically I am calling the function power with an argument value 2, and then that 2 is exp, right? So what happens here? So once I run this, right, and try to find out what is a, what is the type of a. So a is a function, right? So when I run power with an argument 2, so 2 is being assigned to exp, and here exp is being set to 2, and a is now a very same function as assign base, that is it takes an argument and returns that argument raised to the power of 2, since exp has been now 2 because of this, right, power 2. So if I try to see exp, again same issue, local scope, so you cannot, it ceases to exist. When I do a of 3, remember a is a function just like assign base, which takes one argument, right, and raises it to the power of 2, right? So when I do a to the a3, so it basically 3 is raised to the power of 2 and 9. So even after this, a power function or the outer function has stopped executing, the function a still remembers that value, and that property is called closure property. That this means that the nested or the inner function remembers the state of its enclosing scope when called. That is, anything defined locally in the enclosing scope is available to the inner function even when the outer function has finished execution. Okay, now how to change values in enclosing scope. We know like how to change values in global scope. We use the keyword global. Now what we want to do is we need to change the values in enclosing scope, right? So again, this x has a global scope. Then when we write global x, it is basically, we are given permission to change the value of x. So I am defining a function cube which takes a parameter value. Then I am giving permission to change x. Then value is multiplied by 2 and it assigned to x. And since I have given the permission to change, so x is now reassigned. Then I am defining a enclosing scope variable y with the value of 2 and printing that value. Then I am nesting a function, so defining a function called change y and non-local y, right? So this y has been defined in the enclosing scope and I want to change it. So I use the word non-local y. then I'm assigning into y is equal to 100 and the changed value is y, and I'm calling that function, right? So change y. So I run this and I do cube 10. So what is this doing basically? Cube 10, right? So 10 is being assigned to value. I'm giving the permission to change x. So value is what? 10, right? 10 multiplied by 2 is 20 and x is now being assigned 20. Why this is possible? Because of this global x, right? Then y, so remember x is 20, y is 2, right? I am printing the original value of y, and that is original value of y in closing scope is 2. Then the cursor goes, okay, now we have another function and I am giving the permission to change the enclosing scope variable y, and I am assigning a new value, and since it is done, so the change value is 100, right? So when I look at y, what is this going to be? Name y is not defined. Why? Because y was enclosing scope and then local scope, right? So again, same property, since it was not global, so it ceases to exist. What is the value of x going to be? 20. Why? Firstly, it was 5 and it has global scope, and I allowed it to be changed. So this value 10 multiplied by 2 became 20, right? And that is why we have 20. So that is what the LEGB rule says, that whenever you are trying to access a variable, the search is local scope, then enclosing scope, then global scope, and then at the end built-in scope, right? Okay. Now let's understand what are default arguments of user-defined functions. So let's say if a function has multiple parameters and several of them often take a certain value, then to avoid providing the values for those parameters every time we call the function, we can assign default values, right? So for example, I am writing a function power, which I want to provide a base and an exponent, and I'm writing exponent is equal to 1. So if I don't say anything, just return the number basically, right? So basically the number raised to the power of 1, that is same number, right? Raise it to the exponent, restore it in value has local scope, remember, and then we are returning value, right? Okay, run this and I say power 3 comma 1. So 3 is base, 1 is exponent. 3 is raised to the power of 1, no problem. Let's say I write power 3. Now in the last video I said the number of arguments while calling the function should be equal to the number of parameters while defining the function. But here it seems something is odd. I am calling a function with one argument, but the parameter of power function are 2, base and exponent. Why is this possible? Because even if I am not providing the second argument, by default it takes exponent is equal to 1 because we have defined our function in such a way, right? And you see that is the use of default arguments. So 3. But it does not mean, like when I say exponent is equal to 1, it does not mean that every time exponent is going to be 1, right? It means by default it is going to be 1, right? So when I do power 3 2, so 3 should be raised to the power of 2 and should return 9, and it does, right? So this is how we define default arguments. Okay. Now sometimes what happens is that up till now on the previous video and in this video as well, we were defining functions by the number of arguments that were fixed, or that is we know that okay, this function will need these many arguments, like correct number, we need to know the correct number. But it can be possible that at times we don't know how many fixed number of arguments are there going to be, and you want to write a function when there is no fixed number of arguments, right? So for example, let's take, we want to write a function that takes all the transactions made by a person in a month and returns the total money spent by the person in that month. So obviously a person can buy 2 things, buy 10 things, buy 100 things, right? So it can change. So how can we write a function which can do this when we don't know how many number of arguments are going to be? So in that case, right? What do? We use a keyword called star args or asterisk args, right? So what it basically does is, let's say I define a function called total and I write asterisk args. So one thing to note here is the sign asterisk is important, not this keyword args. So even if you write asterisk cow, asterisk buffalo, asterisk dog, asterisk cat, does not matter. All it matters is it should have an asterisk before it. So this means I don't know how many arguments are going to be, right? So I write s is equal to 0. So initialize a variable called x. Then I say for transaction is args, right? S is equal to s plus transaction, and then return the total sum, right? So let's run this, and I say okay, total of these 3 transactions, it returns. These 5 transactions, this returns, right? Now what is basically happening here? So when I write something like this, right, so basically when I am calling this function, right, total, so it is converting this entire input into a tuple called args, right? So again, I have just taken the same thing, just added one more line, print the type of args, right? So basically what is this args? So if I run this, it says class tuple. So what is happening is when I call this function total with any number of arguments, so those arguments are being converted into a tuple, right? And that is why this looping is possible, right? So for each value in this tuple, take that and add that, right, to sum. So how is it going to work? S has been initialized to 0. So for transaction in R, so the first transaction is $22, right? So initially S is 0. So 0 plus 22 is 22. So now the value of S is 22. For next transaction 29, right? So S is now 22 plus 29, right? So this sum is calculated and stored. Now again for 14, right? So this sum plus 14 is stored. So this is how the total sum is being calculated, right? And that is going to be 244, right? Now when I call this function without any argument, what it should logically return 0, right? Because there is a person who didn't swipe his credit card for the entire month, and obviously the total spent is 0, and it does, right? Now what to do if there are variable number of keyword arguments, right? So here when we write star args, so these are positional arguments. What to do when we have variable number of keyword arguments, right? So keyword arguments, to do that, we write double star kwargs. Again, double stars is valuable here, not what is written after it, right? But by convention we write kwargs, keyword arguments, right? These keyword arguments, just like args was being converted into a tuple, this kwargs is converted into a dictionary, and we know dictionary has key value pairs, right? So kwargs dot items, remember in our initial video we learned about functions, methods, objects. So kwargs is a dictionary object and items is a method. Remember we learned method is a function related to an object, right? So items is a method related to the object kwargs. So for key value in this, print the value of key separated by a colon, right? So, and since it has variable number of kwargs, so you can provide any number of keyword arguments, it does not matter, right? So when I run this and I see, okay, so with 3 arguments it returns this, with 4 arguments it returns this, and you see this is the class, so dictionary, right? We can even combine these variable number of positional arguments as well as keyword arguments, right? So for example, I have just copied the code from these lines, so this one and this one, right, and put into one. So variable number of position arguments, variable number of keyword arguments, sum is initialized, and calculate the total. And let's say, let's say these define the number of subscribers gained by this channel on 6 different days, right? And what is the name of the channel, and like what kind of channel it is, right? So I run this and I run this. So it says 244 and then everyday data science and YouTube channel. So yeah, this is the video. I hope you guys were able to understand a lot of things. Let me know if something was not clear. I hope this video was useful, and in the next video we are going to learn about lambda functions, which is again very very advanced form of functions, a function which has no name, and how they can be can save you number of lines of codes for you. So I hope this video was useful. Let me know if the video was useful, and until then I will see you guys in the next video.